Hello, good afternoon, everyone. I have sent a collab link in the chat box, and similar to the previous class, I would like you to go with this link, make a copy of it, and start practicing with me. So, what query Ankit have, I think it's very genuine, and I know you guys need a hands-on programming training. Right now, what I can do is I can help you guys to be familiarized with all the terminologies or Python libraries which can be of any use. If you want to practice on yourself, you have to take a problem and do it on yourself. You cannot learn coding just by looking at a programming course. And why I prefer collab, because it's a online platform and it's very convenient in every respect. I'll let you know how it is convenient in one of today's problem as well. And I have sent the link in the chat box. So I'll sharing my screen, and if you guys have any issue, I cannot go back and see what you have if you write it in chat box. So I would request you to please speak up in the middle, because I'm not able to access the chat box in between of the classes.
Excuse me, ma'am.
Yeah, please tell me.
Ma'am, all the code syntaxes that you use for the models and all,
Yeah.
do you remember them or just we have to take help from any clipboard or something?
uh okay, so it depends on what kind of problem you're solving with. For
Okay.
example, previously I showed you three Python libraries. One was pandas, which if you want to deal with datas, like if you
Okay.
want to read datas from .csv file, you can go with pandas. I showed you matplotlib. That is something if you want to do a plotting of that data. Okay. That,
Okay.
similarly, there is something called numpy. If you want to deal the data in the form of arrays, or in the form of matrices, or in the form of rows and columns, then you go for numpy. So similarly, there are so many different Python libraries, and with the time you will get to know like what kind of problem you have to deal with. You can look for that kind of Python libraries, and that is how you go forward, and you will learn what kind of uh, like which for which problem solution, what kind of Python libraries is needed, and how you can tackle that problem.
Ma'am, like there are predefined models in sklearn. So,
Yes.
like if we have to use any model, we have to just take the code from the website or the documentation
Yeah,
and then use it accordingly. We don't
exactly.
have to. We don't have to remember that.
Exactly, that's what I'm saying. So there are two kind of things. For example, if I ask you, there are 10 numbers given, and if I ask you to find the mean of that 10 numbers, so there are two ways. Either you can uh, make a code to how to find mean of that 10 numbers, like a plus b plus c plus whatever that number is divided by 10. Either you do this like this, or any loop
Yes.
form of that coding, or in sklearn itself there is a uh, inbuilt function that is mean. You can just call it and you can just run it. So it depends
Okay.
on you what kind of like path you choose for your problem solving, which is
Okay.
convenient for yourself, right?
Okay. Okay.
Okay, so shall I begin? I think I'll begin. Okay. So I've put the link in the chat box. Can you please go through it once? So, please let me know if you guys can see my screen.
Yes.
Yeah, okay. Okay. So today's topic is linear regression in Python. So anyone can explain me what linear regression is? I hope you must have gone through linear regression terminology.
Hi, Kaushiki.
Yeah,
Yeah, sorry to interfere. I didn't receive any link. Probably I've joined late. That's the reason. Can you please share that once again?
sure, I'll do that.
Yeah,
So I have
thanks.
again shared the link. it's in the chat box, and I would request you to make a copy of that, so that you yourself, because you cannot do any changes in my copy. If you want to have a practice, make a copy of this collab notebook, that then you can simultaneously run this code. Okay. Okay. So linear regression, can someone please tell me what linear regression is?
Hello, ma'am. Can
Yeah.
I tell the answer?
Yeah, please go ahead.
So actually, the linear regression we have like x and y. We have two variables. So in the in one variable we should have like which variable we want to predict. Like
Hmm.
example, which variable we want to change, like what variable we need to predict. So based on that, one will be independent variable and another will be independent variable. So we have the like graph like straight line plot with x
Okay.
and y. So
Hmm.
that's what we define as a linear regression. But as well as we have the slope. That formula I didn't. I mean, now to say the
Yeah,
formula, but
fine.
saying that one.
So basic gist of linear regression is it's a machine learning algorithm, and we use it as a statistical method. What is statistical method means? We need to find the two variables, as she said, and we need to find, for example, if I'm saying it will rain today, so that is a predictive analysis, right? So how we predict that with a with respect to a variable is what linear regression is. So in short, we have an output and we have a predictive output, what we have predicted. So we have to see how my output is somewhat similar to what that has been predicted. That is what linear regression is. And this term, what we do is that comparing the output and predictive output is called fitting the output, fitting the data. So we'll go back to it. Over here, I'm telling you how Python is used for linear regression with so many examples. First, I would like to tell you what are the 5 basic steps. Like I have divided the linear regression module in very 5 basic steps by which you can know how this linear regression can be used in Python. So the first foremost step is to import the packages and classes. Obviously, like if we want to use the linear regression, we have to import it from in like linear regression is an inbuilt function in scikit-learn. So we need to import the packages needed and the classes that has been already defined in the terms of linear regression. So that is what I did over here. I have imported numpy as np and from sklearn.linear model. This itself is already a scikit-learn. You don't have to do anything. So in linear model in sklearn, there's something called linear model. Linear regression comes into linear model. So what I'm doing is I'm telling ki sklearn from linear model import linear regression. That's it. That's what I've done. And now I'll be running it. So whenever you work with collab, you have to see, okay, so you have to run each and every cell so that the next cell can be run. So this is where my numpy and my sklearn from linear regression is being importing. Second step would be to provide the data. So over here, I'm taking two variables. That is, one is input and one is output. Input I have defined as x, and output I have defined as y. So over here, I've just taken random numbers. Okay, since you can see the first cell has been run with a tick mark, this means my numpy has been imported as np and my linear regression has been called. So now I have taken x as input and I have given some random array and I have called it as from numpy. And similarly, I have given y some variables. I have just given some random numbers to show how things can work. Now, the third step would be to create a model and fit it. So right
Can
now,
you explain
tell me.
the reshaping part?
Okay, yeah. So this um reshape means I'm changing the dimension of x. So if you can see, okay, let's do one thing. I'll print x and y. Okay, let's see. I'll just print x and print y. So if you can see, I'll tell you what does reshape means: changing the dimension. Okay. You can see y is just an array which I have given 5, 20, 14. While x is my dimension has been changed. Why this has been done? Because when we go further, we need our x in one dimension form, in this dimension form rather than in this dimension. So let's see, there is a terminology called dot shape. So we can know what is the shape of that x. So let's see, let's print the shape as well. Okay.
Hello, ma'am.
Yeah, please tell me.
Ma'am, this one dimension can be considered as vector form.
Vector form in what sense you're taking vector form as in?
Means column.
Column. Yes, yes, exactly, exactly. See, can you see there are two things? This one, and there are two big brackets. One big bracket, and these are like one big, like another big brackets which has been segregated. Over here for y, this is just one big bracket. So this means if you will take it as 1, 2, 3, 4, 5, 6, it is just one row into, this is more of like 6 rows into one column, and this is more of like one row into 6 column. So this is just to do the matrix multiplication. I'll tell you, in matrix we have something called, when we do a matrix multiplication, the rows and columns is something which plays a major role. For example, I've told this in previous class as well. So if we have a matrix A and matrix B, and both of them have some rows and columns, right? So the column of A and the rows of B should be equal. Then only we can do the matrix multiplication. And that is why we have to do the reshaping. So this reshape means to change the dimension of the array. That's it. Am I clear now?
Madam, is it something like row vector to the column vector?
Exactly. Exactly.
Okay.
Okay. So moving ahead. So now, since our data has been provided, we are creating a model and fitting it. I told you what fitting the data means, which means we are trying to make the output as nearer to as my predicted value is. Okay. So the linear regression is already a inbuilt function which we have called it, right, using our sklearn. So over here I'm just calling linear regression dot fit. Fit means it's again a inbuilt function, and I'm giving this variable which is my x is input and y is output. So I'm telling this that you have to fit the linear regression model with variable x and y in this variable called model. The fourth step would be, see, these are just the step which I'm first initiating and telling you guys. In the next further examples, I'll be solving some real-time example, and this can make sense what I'm telling you. These 5 steps, just remember these 5 steps. Fourth step would be to get the result. So once my model is fitted, we have to get the result. Okay. So linear regression is always in the terms of a straight line, right? So we have so many datas, and we are drawing a straight line out of those datas to know how many predicted values are nearer to our actual output, right? So if you know the equation of a straight line, that is more of y is equals to mx plus c, where y is my output, x is my input, and m and c are, m is called as slope and c is called as intercept. So when we fit the model, that means how it determines that value of x and y are very near to each other when the values of m and c will be very, that can be what, modified, right? For example, what I meant is, if I'm telling you y is equals to mx plus c, now I'm asking you at what values of m and c y and x will be equal. So you can see if c will be 0 and m will be 1, my y and x will be equal, right? But that is the ideal case. That doesn't happen in the real scenario. So how we are going to do it? That is what we use the term fit. And that is how we calculate the values of M and C such that Y and X could be as much close as it can be. So doing this, we have calculated the values. So this model is from here, which is telling this linear regression what has been fitted. Put the values of those. Find the score. Score means the values of the coefficient of determination. This R square is a coefficient of determination, which means how much error it is occurring between X and Y. So this is what it means as coefficient of determination. The next step would be to find the model intercept and model coefficient, which I already told, that is M and C, which is slope and intercept. So when we, yeah, so my intercept is
Ma'am,
5.63. Yeah, please tell me.
ma'am, please explain the score point.
Which one?
Score.
Score. Okay. So score is an inbuilt function which is just giving me the output result. Okay. So we have the equation y is equals to mx plus c. And I told you, if we have to, our aim is to find what can be the value of m and c so that y and x can be equal. So in ideal cases, if c is 0 and m is 1, then only my y and x can be equal, right? But that is not the case in real scenario. So first you have to find, if we have to find the value of m and c, we have to find how much error is in this equation. So that is defined as r squared, that is coefficient of determination. So score is just an inbuilt function which gives this coefficient of determination, which tells how much error it is. Okay. And on the basis of that, we are calculating our slope and intercept. That's it. So this again, this intercept and coefficient, this values are inbuilt function. Inbuilt function in where? In linear regression itself. We have imported SK from sklearn, we have imported linear regression, right? So from those linear regression, these score, this intercept, and these coefficient are defined, and that is how we are calculating intercept and slope. So now we can say, if we want to know when my x and y will be equal, then the value of m, that is slope, should be 0.54, and the value of intercept, that is c, is equals to 5.63 for a straight line.
Ma'am, can you please explain the term error? Like how R square defines error?
So r square, it's not okay. See, again I have to tell the same thing. If we need to find y is equals to mx plus c, I have to find what will be the value of m and c. Y is equals to mx plus c. This is the equation of a straight line. Okay. I need to find the value of m and c such that y and x should be equal. For that, in the ideal scenario means when, which doesn't exist in real life. In real scenario, it doesn't exist. So in that scenario, the value of c should be 0 and m should be 1. But that doesn't happen, right? There should be some error, because whatever input I'm giving, I cannot get that output, or whatever prediction I'm doing, that cannot be the exact scenario, right? So to find what is the difference between them, there will be some error. I'm referring it as error, but that is called as coefficient of determination. That terminology is called as coefficient of determination, which is called as r squared. So we find that r squared with the help of this core inbuilt function when we give this x and y our input and output variable terminologies. Am I clear now?
uh, Once again, if we find the coefficient of determination, what we will do with that value, like points, point seven
So
one five
this
eight,
tells,
etc. We got.
yeah, so this tells how much deviated my x is with respect to y, or I should say how much deviated my output is respect to my input. Am I clear now?
So yes, Now the another question come up is like with this value,
Ma'am,
do we have any other reference
Sorry,
value?
sorry.
Like say for example,
I'm
if it
sorry.
is more,
Can you please repeat? Sorry, I'm so sorry. Yeah, please
yeah,
repeat.
fine.
Yeah,
Now we got the value, so the
yeah,
value it's been like error. So with that, we can find out the difference in x and y. So
yeah.
what we need to do, like 0.71, do we have any uh, say like assumption like point more than point 0.5 or 1
Yeah,
or
there is, obviously, there is. That is the interpretation part. Obviously, there is. Right now, what I'm doing, I'll show you what you are saying. It exactly makes sense. How this like deviation means. I will show you with respect to a graph and with respect to an example. Right now I just wanted to tell you the idea of how the like steps work. Like first is to call your classes or your like Python libraries. Second step is to provide the data. Third is to fit your model and call your model. Fourth is to get result, and fifth is to predict responses. This is just the steps I'm telling. What you are telling, how to visualize it and how to interpret it, it will obviously come in. Like I'll show you in examples.
sure, okay, fine.
Yeah.
Ma'am, ma'am, can we simply say coefficient of determination as error of the model?
That's what I am referring to. It exactly not error of the model, but this is what, like how my, okay, it exactly is not error, but it means my predictive values, how much it is deviated from the output. I'll show you with a graph. Just be patient for like 5 minutes. Just let me complete this step and we'll go to a example, and then I think the your questions will be solved. Because this have just come, I think, abruptly, so you might be like, okay, what is this? Just give me 5 minutes, okay? So I'll just move forward. So number fifth step. Yeah, tell me.
Ma'am, why we have written f besides the print? Because in Python we can without f we can print the statement.
We can. I just wanted to like I obviously we can. There's no use of that. It's just I wanted to show like I was doing something. It's okay. You can remove the F and you can print it. There's no issue in that. Obviously.
Okay, ma'am.
Yeah. So okay. This F is actually for a like another version of Python, and that is why I have to mention it. And that is what I was mentioning in initially, that different Pythons have different ways of writing it as well. And that is why I don't want to work on any platform other than Collab, which is a cloud platform which doesn't care about environment variable or the version of Python being used. So step fifth is predict responses. Now we are predicting what our responses would be, and this how we have termed it as y predict. Again, predict is an inbuilt function, and we are predicting our results. So these are the results, and don't bother about these results. These are just the result. What the data which I have provided with respect to that what kind of responses we can predict. Okay. Now let's. These are the just five steps you have to remember. Now let's work into an actual scenario. Okay.
I have one question
Yeah,
before
please,
you move
please.
on to the,
Yeah,
and it's a high level conceptual question.
yeah,
So, how do you actually know which function to call? So, you have hundreds and thousands of already built in functions into the libraries.
exactly,
So, for example, for predicting something, you're calling the predict function.
exactly.
And then for getting the score of the linear regression, you're calling score. But
Yeah,
how would I know? Do you have some kind of a list or a search option somewhere to
exactly.
figure it
Yeah,
out?
yeah. So if you will go to scikit-learn documentation. So right now,
Okay.
whatever I'm doing is I'm using scikit-learn,
Okay.
sklearn, which is a Python library.
Okay.
If you go to that website, just you have to write sklearn,
Okay.
right? And you if you just write sklearn and if you go to its documentation, you will get all the see, these are classification, regression. You just have to go to getting started, that the basics, that documentation of it. And what, see, there is user guide over here. And now whatever you need to know, like which function to call when and what function to
Okay.
call when,
Okay.
it's all mentioned here. Okay, you
Okay.
just
Okay.
have to like practice and know what you want to know. See, everything. So these all are the Python libraries which has been made by someone for, you know, user convenience.
Okay.
So
Okay.
for
Get it.
that
Get
you
it.
have to know what you want. Like for example, over here I want to know that the output which I have got, how much it is. Like now I need to know the model which I have created, if it can predict something, like what will the prediction of that model. So I know for that there is something called predict.
Okay.
Similarly, if I wanted to know what to calculate out of it, like coefficient of determination, for that I know there is something called score. So this is how I'll
Okay.
call it, this is how I'll do it.
Okay. So we don't necessarily need to remember this.
You have to remember it, but not specifically these all things. You just
Okay.
need
Okay.
to know ki, okay, this is your problem, and you know need to know where to look for it.
Sure. Sure.
That's it.
Thank you. Thank you so much. It helps.
Yeah. Okay, now let's do how, if we have to, like, let's generate some random data. From now I will be dealing with two problems. One will be I'm generating some random data like that from the Python itself, which I'll show you how. Second, I'll be dealing with calling a .csv file itself, that is already a full-fledged data, and how to do a predictive analysis, that is linear regression on that data. So first problem is I'm generating a random data, and my solution, what is my problem is I have to find the predictive values, and I have to see how predictive values and actual values differ. Okay, so for this, I since I'm generating a random data, I am calling NumPy, I'm calling pandas PD, and now you will ask, okay, it's not necessarily that you have to import everything at the starting. Okay, just start working on your program. For example, if I am generating a random data, I that time I didn't know if I need pandas or matplotlib or not. Okay, so imagine I have just written import numpy as np. You can always come back again and write another libraries which you need to call, or over there itself you can call that another library. That's what I meant. So now,
Ma'am, can you explain pandas significant here?
yep, I'll tell that will come at later stage. So for example, Abhi, like right now I just need to create a random data. So I have just imported my numpy as np. So np.random.seed. So this random is an inbuilt function which will randomly call some numbers. And this seed means starting from taking that zeroth of number. Okay. So what I'm doing is I'm calling x, which is my input. I'm telling multiply, like I'm telling that take its standard deviation as 2.5 into np.random dot, this randn means generating a random number with a value of 100. Like you have to generate 100 arrays. Okay, you have to generate 100 arrays. 100 arrays means 100 numbers which will be having a standard deviation of 2.5 and a mean of 1.5. This can be any values. This is not confined to 2.5, 100 or 1.5. This can be any values. Okay. Then I'm taking the 100 residual terms. Residual terms means that when I told you y is equals to mx plus c, that c terms, that intercept term is always considered as a residual term. That is an extra term. Okay, so I'm again telling take 0.5 as standard deviation and just create a random, 100 random residual terms. Now, again for y as well, I am giving some, because I have to generate some random numbers, right? So you can give any kind of number, and don't bother about this generating random data. It's not at all necessary. What necessary right now is to know how linear regression works in. So just think about this step. This step is something where I'm generating some data. That's it. Where two data I'm generating, even forget about residual, two data I'm generating. That is, one is input and second is output. Now the question comes, how pandas is there? So I need to create the data frame. Now, what is data frame? When I need to know what kind of values that has been generated as 100 datas contain X values, and what kind of data generated as this Y using this X data is, because see, um, we have to know what 100 datas has been generated. We have to see. So we have to create a data frame. So how that data frame can be created? Using my pandas. Okay. Just run this and you'll know. So two basic steps I have done over here. I have created random data, which is input and output. I have done, I have created the data frame. Data frame is this thing, what I'm saying. Creating an X and Y with 0, 1, 2, 3, 4 numbers. So there will be hundreds of data. If I'll write in data frame like 10, if I want to show you 10 datas out of 100 datas. So these are the 10 datas you can see. Top, starting from 0, these 10 datas are there. So these 10x random values has been generated. These 10y random values has been generated. That's it. Okay. Now,
Have a-
yeah,
I have one question.
yeah,
So here we use a random command. So
yeah.
by every click, the value of X and Y will change, right? Or it will be constant.
The for every click, see, it can change. But what I am doing is I'm multiplying it with 2.5. I'm multiplying it with 1.5. That is, I'm giving some specific standard deviation and specific mean, right? So it can take, for example, random 100, like 0, 1, 2, 3, for some random number it is taking, and it is multiplying and giving me some number. So let's check if you're telling, which I'll tell you, will see. Can you see the number has been changed? Initially it was 5.7, now it is 5.9, right?
Yeah, that's what. Yeah, that's right.
Exactly. So obviously it will change. And how my X will change will depend on how my Y will change, depend on my X, right? So
Ma'am,
that
but
is,
you are fixing a seed. Then how will it change? Like we have used numpy.random.seed 0.
yeah. So
When we fix a seed, then the random numbers remain the same.
okay.
Zero is the first value, right? The value should comes after zero. Like, is
Okay.
that make sense? Correct?
No, no. So what she's telling is making sense. I was about to come to that point. But if, okay, let's do it. Agar main ye seed, I'm not keeping that seed, and let's see what my result will be. So now if you see, my value has been changed, right? Why I have kept seed 0? Why I have kept seed 0? Because if I'll keep changing my random data again and again until unless I'm again like running this program, then hundreds of data will be changing, and my all the outputs will be changing. So what I'm doing is I'm telling right now that keep this numbers constant. Okay. So if we will see, that is what C0 is. If I see, now you can see 5.91, 4.7, it is fixed, right? If I remove this C, my values will change. So I cannot afford my memory to be full with again changing data again and again and again. So now, whenever I'll execute this cell, every time my X and Y will change. Every time my X and Y will change. But what is the disadvantage of that? That my memory will be full. So I have some limited memory when we work with data, when we work with programming. Apart from that, our two more important thing is to look for the memory and to look for the time, how much time it takes to execute a data and how much memory it is computing. Right now it's very small data and it doesn't matter, but instead of 100 datas, if I increase it to 1000 or 10,000 or more than that, then it will take a lot of time to generate the data. It will take a lot of space. So that is why I'm keeping my generated data as constant. That's it.
Uh, when we are using
Yeah,
this
please tell me. Someone is saying something.
when we are using this seed, so
Hello,
it
I'm
is
sorry, I'm not able to hear you.
when we are using Let's see
I'm
it here.
sorry, I'm not able to hear you. Okay. Okay, can you please type it? Mm, yeah, you can say that. You can say that thing. Yes, exactly. Yes, it is a random. Okay, is it clear or like should I move forward? Because we have less time left.
Okay, one question. So instead of putting it as a zero
Yeah,
for seed function, if I put it as five, so basically that means the reading will start from the fifth element,
exactly.
right?
Yeah,
So that's the only difference. Now, if I don't do seed,
yeah,
that the entire database gets randomized.
exactly.
Okay.
Exactly. That makes sense. Okay, so now,
Can you please show this practically?
sorry, what?
Like what he was saying, can you please show it practically?
Uh, I would love to do that, but then you guys will be left with what I'm about to show because we have less time. Okay, okay, let's do that because I this is what you guys have to do, right? If I keep doing all this stuff, so that's not like I'm not be able to do that in 1 hour. I'm so sorry for that. So what he meant is, this seed tells zero means like my values. This whatever values I'm showing, that should be constant from the very first element. Okay, if I'm keeping it as 5, this means my value is keep my values constant from the sixth value. Why writing 5 means 6? Because from 0 it is counting 0, 1, 2, 3, 4, 5. So this means sixth element. So keep the constant from till sixth element. So this is what does it means. And these all please try to do it on yourself, and have doubts then ask in the forum. Okay. So there are two kinds of variable which we are dealing with, obviously. Um, the output variable, and that has to be predicted, and the input variable, right? So if we need to, so okay, um like not rushing into it, let's focus on this equation. So what does this equation means? So ye is my predictive value, and alpha and beta are the values which determine. This is similar to y is equals to mx plus c. So alpha and beta are two parameters which is used to minimize the difference between my predictive value, that is ye, and my output, that is y. Okay. So firstly over here, I'm see again, I told you, like mean is a defined predefined value. So I'm calculating mean x and y. This is a totally different method which I'm trying to show you guys. So I have calculated my alpha and beta. How I have calculated my alpha and beta? So to calculate alpha and beta, there's something called covariance. If you go into the theory of linear regression, you will know there's something called linear shift method. In that linear shift method, the to calculate the alpha and beta, we have to find the covariance of that value, mean of that value, and variance of that value. So I'll not get into how to calculate the alpha and beta. I just wanted to, yeah, this is a theoretical part where you have to find alpha and beta value using different methods. And the methods which I am using it is called as OLS, that is
Ma'am,
linear shift method.
alpha and beta are eigenvectors.
You can term it as eigenvectors if you are talking in the terms of linear algebra. If you are talking in terms of straight equation, so you can term it as slope and intercept. Over here, I'm just generalizing it as a two parameter. I'm just generalizing it as a two parameters which is used to minimize the difference between my predictive value, that is ye, and my output value, that is y. That's it. So however you want to consider it, you can consider it. So now the main important thing I want to show you is, okay, my alpha and beta has been calculated, that is Now I can know what my y predictive value is. Okay, if you want, I can just print the y predictive value, but that is of no use because we don't want to see what my value for y predictive is. So these are the predictive values for y. So the data set that has been generated, this is what the predictive values of y is being given as with calculating alpha and beta. What I wanted to show you is this graph. So how you have to define between actual versus predicted. So these dots you can see, right? So these dots are showing how my, see, there's something called x and there's something called small y. The small y is my predictive value, this x is my input. So the plots has been this is a scatter plot which has been drawn between the input data and the predictive data. Okay, input data is called as actual value and y is my predictive data. So these are small like points which has been calculated, and this straight line is the line which is telling that if you will, the values which lie on these lines is what makes it a fit data. What does it fit data means? This, the values lying on this straight line, that is a blue line, is the values which are nearer to my actual data. So the red dots on blue line means the predictive value which is very nearer to a actual data. So among all the data, and now remember, now go back to the step 4 which we calculated, where I was telling coefficient of determination. So we calculated some coefficient of determination, that is r square. That is the distance. So this line, from this line, how much distance, how much error that value is giving. If you're taking a random point over here, for example, if I take this point and I need to know how much this is deviated or how much it's different from the actual value. So how we can calculate this? With the help of that coefficient of determination. That again is a theoretical part, and I really don't want to get into it because I can tell you, I can totally explain you guys, but not into in this class, because this is more of how you can do it practically, how can you can do it in Python. So if you have any doubt related to theoretical part, you're most welcome to ask me in the forums or in any classes where theoretical part is being taken up. Okay, so again moving right over here, again I am okay. So first thing what I did was I created a random data and I predicted the values and I plotted data, I showed you. Now I'm taking a real time example. There's a platform called Kaggle. Kaggle is an online platform for coding itself, and on Kaggle there are different kinds of data sets available. So from that Kaggle, for linear regression, I chose one data set, that is advertising. If you will just write advertisement data set on Kaggle, you will get this data set, or you can get a lots other data set. So what that data set was, it consists of 4 different categories, that is TV, radio, newspaper, and sales, and it is predicting which data set have maximum number of advertisement. Okay, and how the advertisement differs with respect to different mode of mode of communication. So there are 4 types of communication, sorry, 3 types of communication according to which my sales is depending on. So TV, radio, and newspaper. So the question was, how you're predicting the sales with respect to TV, radio, and newspaper advertisement, which is giving the more sales. So my sale is the value which is being given as y. My TV, radio, newspaper is the value which is given as x. And now I have to do a prediction that among this, which is giving me the, which will give the better output, better sale, and where should I go for advertising my product. Okay, this was the question. Am I clear with the question at least? Because this is a really interesting problem, and I think this will solve most of your question related to linear regression and how to solve it in Python.
Clear.
Yeah. So over here I have just taken a variable Edward. PD is the pandas. And why pandas? Because I need to create my data in the form of data frame, because my data is in the form of .csv, and csv is it's CSV means how you can see the data set in an Excel sheet. Okay, so full form of CSV is comma separated by variables. So the data will be just a, like, if I just not show you TV, radio, newspaper, sales, 0, 1, 2, nothing, I just give you data set in the form of 230.1, comma 37.8, comma 69.2, comma 22.1, comma 44.5, comma like this. You'll not get anything, right? You'll be like, what is this? I don't know what this is. How to interpret this data? That is where we need pandas, because that display our data in the form of data frame. What does data frame means? Representing the data in one part, in which we can understand. That's it, in a simple term. So again, I have called my data set pd.read csv. This is a inbuilt command which reads the csv file, and I have printed the what are the data. So just I've given head again, by default 5. You can give it as 10 as well. You can just, if you want to see the 10 data. So these are 10 data. Now there's something called stats model. So what does stats model means? I want to, like, okay, so over here with this example, I'm showing you results with two methods. One is stats model and one is sklearn. Sklearn is more of, predicting your values, just the values. It will tell you, okay, final output is this. But stats model is something which you can visualize, you can see in the terms of scatter plot or any other kind of plot or statistics, mostly in that kind of term. So for that, I'm calling stats model dot formula dot api as smf. Okay, so again, I need to see how my sales, I have to fit my linear regression, right? So to fit the linear regression, I'm putting my data as Edward. What was Edward? Which has been given as input. And my data set, I'm telling from sales to TV. So if you can see, from sales to TV, this all data set I'm telling you. So I'm fitting my data set, and this OLS, again, this OLS is a method called linear stretch, which I already told you. It's a method already defined. In a linear regression, it's a method defined. So my model has been fitted. Now I need to predict the values. So what I need to predict? My sales. How much sales has, which method gives the best sales, or how much it can be, like, what values can be predicted. So I told you, using this, I'm showing using a graph. So let's go with the graph. If you want to see, I want to show with respect to TV advertisement, how my sales is fluctuating with respect to TV. You can do this with respect to newspaper. You can do this with respect to radio data as well. Over here, what I'm showing is how my sales is very, like, getting different values or different results with respect to TV. So my y is my sales, and my TV is my x. Okay, so if you can see, this is what the result I get: TV advertisement cost and sales. So if this straight line, this red line again shows this, whatever the values on this straight line will be giving the sales according to your TV advertisement cost. Okay. Now this was my model has been predicted and all. Now you cannot do it every time another new query will come, right? So if you want to again predict a model, predict a value on this model. My model is trained, my model is fitted, everything is done. Now we know if my TV advertisement value is, for example, 150. So my, if we'll go with this straight line, so my sales will be around 10. So 10 can be in whatever amount you know. Now I need to check with another value. So let's take a new X value, new input data, which my model doesn't know. That is 400. We predicted our value till 0 to 300, right? So now let's take the cost of TV advertisement in is 400. Now I want to know what will be the cost of my sale, how much sale I can get, what will the result of that. This is where linear regression comes in. I don't need to again do all of this all over again. I don't need to find what will be the my sale value will be. So if my x will be 400, my sale will be 29.16. This value you can check with n number of values. If I want to check it with 500, let's check. I can get I'll get the sum value. This is what sale is, 34.7. So I think I'm now clear how this linear regression works in real time problem.
Ma'am, there are so many assumptions related to the linear regression that like my error term should be normally distributed and my variables should not be correlated.
Yeah,
There should not be heteroscedasticity in the data.
yeah.
So why we have not checked these conditions?
Okay. Over here, what I am doing is, I'm just calling the inbuilt function. What you are telling is when we have to deal with, if first there are two things. First thing is the question or the example which I have considered is not a complicated one. It's a very simple question which can be done without checking those conditions. Very first important thing is. Second thing is what you are telling is can be checked over here as well, but I don't need to do that because I am using this OLS. What OLS is a predefined function for like stats model. If you know OLS, it's a model for linear regression which already have these methods. So for this particular Python library, the things you have told is already inbuilt. So when we are calling it, we don't need to check it again and again and again. So there are two things here.
Now, OLS means ordinary least square. So we are just defining the method that the method is ordinary least square.
Exactly.
What I'm talking about is the assumptions before applying ordinary least square.
That's what I'm saying. That's what I'm saying. For the first most important thing I told you is the question which I have taken over here is not at all complicated. That is needed when we are dealing with a complicated data set or complicated data. So over there, we have to be very cautious about the result which we are getting. We have to see the result which I'm getting is correct or not, right? So to check that correct, we have to go with certain assumptions which we needed to do. Over here, I'm just telling you how you can perform a linear regression in Python with a very basic example.
So OLS is the pre-built model.
It's a linear regression method. Okay, it's a linear regression method which is already predefined in linear regression model, which I'm just directly calling it. Like how I called score, how I called predict, how I called fit. That is how I'm calling OLS.
Okay.
Now why not, these plots are not intersecting on a x-axis?
Okay, because that's what.
Y-axis, why?
Yeah. That's what. It's not necessary that it has to intersect on the like origin or x-axis or y-axis. That fit line means that this fit value must just tell you from which values you need to see among all the deviated values, among all the given output. So over here we have TV advertisement cost, and depending on TV advertisement cost, my sale is dependent. So if my TV advertisement cost is increasing, my sale will increase. TV advertisement cost is decreasing, my sale will decrease. It is something like this. A linear dependency is there. That is what linear regression is. So I need to find if I have a certain value of TV advertisement cost, how it is affecting my sales. But how to find that? So this is one of the method that is called linear regression, and in this I have used a model called that is OLS model. Okay, so what we do is we have find the different predictions that is in the terms of blue dots, and this red line shows where among all these blue lines which is your the best fit means which values you should consider the most, which will give you the maximum true result or nearer to the true result, or if we talk about the predicted values and the output values, so main aim is how my ye is very much nearby to the y, that is जो output आना चाहिए था उसके nearer कौन सी values दे रही है. So those values that will give which lie on this red line. Now am I clear?
Ma'am, is it like a best selection of features?
it, it's at first thing it's not features, it's data and values,
Yeah, yeah,
but
ma'am.
yeah, that
Data,
is
data.
exactly what it means. And the assumptions you're talking about, obviously we have, there are question, there will be problem, you have to do it, but in this scenario it is not needed. That's what I want to say.
Okay, so now the latest one you shown that if it is excess 500, like the TV
Yeah,
advertisement cost is 500,
yeah,
we are getting the value output as sales as
point seven, yeah.
34.7072. Yeah, but this is approximation value. So generally, if we are giving approximation value, there should be a limit we used to give, like from this limit to this limit, say 34.70 plus or minus some tolerance value which we are defining,
Exactly,
right?
exactly. So this is
So
what
how
she,
to get that tolerance limit?
that's what I'm saying. See, over here, I have not done those assumptions that what she was talking about. That, plus minus thing that can be, that is there actually. But I have not done it because I don't, right now, it is not like necessary over here in this result. I just wanted to show you how my, predictive values and output values, my linear regression can be there. How I can take a real time example and do a prediction. Okay.
Okay, fine. And I
Ma'am,
have
ma'am.
Yeah,
yeah,
please.
I have one more question on the same plot.
Yeah,
Right now, the plot which is showing is only for the TV advertisement.
exactly.
Okay, so with this is the output, this is the input when we are giving, this is the output what we are getting on it. But
Mm-hmm.
I want to compare other features, like instead of TV, I want to check, I want to see the consolidator. So in one plot, I want to see which parameter. Like
You can
here,
do
we are
TV
getting
then.
one.
I
Yeah,
got you.
we
Yeah, please go ahead.
yeah. So now we have one red line. So this red line is formed based on the data which we that based on the blue dots. Okay.
Mm-hmm.
So similar way, there are other two more
Yeah,
medias up there.
that
So
is
I
the
want to
problem.
plot
Yeah.
three different lines so that I can make a conclusion without
Mm-hmm.
seeing the value. We
Mm-hmm.
can we plot into the one plot?
Exactly, we can do that. Right now, I showed you one variable linear regression. What you are talking about is multiple variable linear regression. That
Yes.
exactly what we can do is we can do this, but there is a that there will be slight different coding for that. That's it.
Okay.
Yeah,
So, but again, we need to change all the coding stuff.
not the whole of coding. What I have showed you is the base level. This is like
Okay.
I have told you this is how things are done. Apart from now, whatever you want to do is you can take forward to it. What you are telling is obviously is done. It is not like you have to done one and one and one. This is just an example and the basic which I need you to know.
Ma'am, what if we have our real time data in Excel and we have to import from the Excel?
So .csv file is an Excel sheet itself. You can save your Excel sheet as .csv. When just right now, if you'll go, you will just write X and Y, write some random values in this, and you can see in Excel sheet itself, there's an option of importing your data in the form of .csv, and then you can call this data. Okay, so this is like, let me just complete it. Just one point is left. What I told you right now is in the form of stats model. Now, we are dealing with scikit-learn. Just let's go with the scikit-learn. So I'm doing with TV and radio. I'm doing the predictions, and this is just I wanted to show in terms of like over here. Now there will be no graphs and model. There will be in terms of alpha and beta, which you can call it as intercept and either slope or coefficient. So my alpha and beta has been calculated. My model has been fitted. Now I can predict my data. So this data has been predicted. Now again, if I want to know, I want to predict my new value. I can predict it. I took see, what you are talking about was if I want to predict between two values, right? TV and like any other option. So I have taken over here TV and radio as two predictors. That is over here I'm showing multiple linear regression. And I want to know how my advertisement sales value will be predicted. So 300 is my new TV value, TV advertisement value, and 200 is my new radio advertisement value. And now I need to know the predictive sales value. So you can see the 42.4 is my new sales value. So even this you can do. But over here, using sklearn also you can plot a graph, but then you have to call matplotlib and you have to do other scenarios. So I have shown you just using the values. Okay. So this what you are seeing over here, these many values, these arrays, this is what has been showed over here in terms of these dots values representation. This is exactly what each dot represent each values over here. Okay, am I clear?
Yes, ma'am.
Okay, so this is what linear regression in Python is. I know there will be some queries and some questions obviously which will be going on with you. I would suggest you to do two things. First, go through the basics and theories again. Come again and go through this Python coding again. And if you have any doubt, just ask me, and you can contact me via forum or any other platform, and you can perform your own, problem solving question to make more clarification on this question, like on this topic. So,
Can we get the recorder section of the this
yeah,
one?
I think yes, obviously. All my recorded sessions are being like uploaded on YouTube. What I'll do is I'll just paste my YouTube. Just give me a minute. I'll just paste my YouTube channel. This
Uh, yeah, you can paste it in the chat window, but can you just share this information into the email so that others also will get
See,
come to know
actually,
those
I
who are
don't
not?
have. Sorry, I don't have access to all the like information section where you are being notified. Those are the responsibilities of other TAs. I
Okay,
can What I can do is I can share you the channel list
sure,
format.
please. Yeah,
I'll
please.
do that if that can help you guys. I think
And
Yeah, that,
also, on the Swayam portal, when you actually go to the live interaction sessions, that opens up a file. In that file, you have the link of all the YouTube videos.
exactly. So we all, everyone, all TA, we used to put our
Yeah.
slides and this everything, videos and everything on that. So you can please take it from there. Anyway, I
can you
have
show me? Can you show me that? Just tell me where it is in Swayam.
I
I
can do that, but I don't know whether I can share it or not.
Yeah,
Sir, on course page, at the bottom you will get a link that the problem solving session. So there you
Correct.
can hit, you get a link for the click.
oh, okay, okay. Yeah, I can
So
see
you
that.
click on that, and it opens up a OneDrive link. And in that OneDrive link, you will have an Excel spreadsheet wherein there is a link for each of the video for